Today we're going to start factoring, and factoring is one of the most important topics in math as far as when you move forward into future classes. And it's pretty simple, but it's also one of the topics that students struggle the most with. So you really want to kind of focus and lock this down and try to really understand what's going on, because if it clicks, it's pretty simple. What we're going to start with is a quick talk about what monomials and polynomials, right? So mono means one. You might have heard like mono versus stereo, right? A stereo has two speakers. There's two outputs coming at you. Mono just means there's one input source. Like any speaker would have that same source coming at you. Poly just means many. So if we come and look down at this, this has one term. So this is a monomial. And this has two. So two, like you think of a bicycle, this is a binomial. This has 1, 2, 3 terms. And notice when I say terms, a term is a group or an expression separated by a plus or minus sign. So this is 3, like a tricycle, is a trinomial. And when we say poly, we just mean many. So typically we would say any of these we could call a polynomials. These are polynomials, okay? And messed up there a little bit, no big deal. Okay, so that's all we mean. Monomials versus polynomials, we just mean these terms, these expressions that have multiple terms, or in the case of the monomial, just the one term. So that's all we mean. Now, multiplying monomials and polynomials works the same way as multiplying any other terms, right? We've already covered example 1. 2x to the second power times 3x. We're just going to multiply the 2 and the 3. We have 6. And then x squared is x times another x is x to the third. So all we did was we multiplied the like terms that we had there. And that's what we covered in the last chapter. But now when we go and we see down here what we've got, just keep in mind we're going to distribute this 2x squared just like we would anything else, right? So 2x squared times 3x is 2 times 3 is 6. X squared times x, we just saw, is x to the third. And now I need to multiply the 2x squared times the 1. And obviously, that's just going to be 2x squared. And because it's plus, it'll be plus 2x squared, okay? Lastly, moving over here, we're going to multiply. We're going to distribute the 2x squared to each term inside the parentheses. So times 3x squared, then times x, then times the negative 1. And just be careful of the signs. So 2 times 3 is 6. X squared times x squared is x to the fourth. Now, we're going to be multiplying the 2x squared times the x. So 2, there's just a 1 there. I could imagine the 1 next to the x, so it's just plus 2. X squared times x is x to the third. And notice it's plus because this is positive and this is positive, so we're going to end up with a positive. Okay, so now 2x squared minus, or times negative 1. So it's positive times a negative, so it's going to be a minus. And times 1 just leaves me with 2x squared. Okay, last thing before we move on. Each of these things that we multiply together is a factor, right? So this, what I got, is my product. That's my result when I multiply these two things together. But each of the things that I multiply together, that and that, are factors. Remember, factors are just the things, the expressions that we multiply together. Again, up here, 2x squared is a factor, and 3x squared plus x minus 1 is a factor. So these are factors. And what we end up with after we multiply our factors together is our product, right? When we multiply, we get a product by multiplying together factors. And this idea of factors is going to be really important as we move on in the lesson. One other quick note on factors, right? The first thing is, even something as simple as 2 times 6, each of these are factors. These are the things that you're multiplying together to get 12. So 12, right, is your product. And 2 and 6 are both factors. So the things that you multiply together to get your product are factors. And it doesn't matter if they're as simple as just a number like 2 or 6, or a more complicated expression like 2x squared down below, or even something in parentheses like that binomial 3x plus 1. One last thing though. So what we did here is we said, and we already did this in the last slide, but we multiplied each of these factors, 2x squared, times 3x plus 1, and we got 6x to the third plus 2x squared. And so the one thing I want to drive home before we get to the next slide is that when we move it in this direction, we were multiplying. And all factoring is moving in the opposite direction. So if you go from the product and you find the factors, this is called factoring. And really, it's dividing if you think about it. And what you're trying to do is figuring out what are the pieces that we multiplied together to get our product. And the last thing I want to drive home here is if we look at the 6 and the 2, you can think, what's the greatest common factor between them? Well, it's 2, right? We could take out the 2, which sure enough, we had there. That's what we multiplied. And then if we look at the x to the third and the x squared, what do they have? What's the greatest common factor? Well, it's x squared, right? We could take an x squared from both of them, but we could not take an x to the third from both of them because this one over here doesn't have enough. That's another way to think about it. What's the biggest thing we could divide each of those terms by, right? We could divide the 6 and the 2 by 2 because they each can be divided by 2. And then x to the third and x squared, we could divide each of them by x squared. We could take an x squared from each of them, but we could not take an x to the third because this term doesn't have enough, okay? So moving in the one direction is multiplying, but moving in the other direction is factoring. So now let's look at some examples and remember what we're trying to do. We're looking for the greatest common factor. And what that means is what's the biggest piece, the biggest expression that we can divide each of the terms by. So I'm going to look here. I have 4x and I have 12. And I can divide each of those by 4 if I'm just looking at the numbers, right? 4 will go into 4, 4 will go into 12. I can't divide each by 12 because 12 doesn't go into 4. So I can pull out the 4. And now I'm looking at the x's, and I have an x here, but I have no x here, so I can't take an x from each of them. And the greatest common factor has to go into all of your terms. So I can only take out a 4, and what I'm going to do here is I'm going to write down what do I get left when I divide each term by 4. So this divided by 4, well, that's just x. And the 12 divided by 4, well, it's minus 3. Notice the negative there. Okay? And so this is what I get when I factor 4x minus 12. And you can always check your work because if you multiply your factor if you multiply your factors again, you should get exactly what you started with. So 4 times x is 4x. 4 times negative 3 is negative 12. And sure enough, that is exactly what you started with, so you know that you factored correctly. Okay, moving on to the next one. This is a little more complicated, but again, I'm just going to look at the coefficients first. So I have a 4, a 2, and a 2. I could factor out a 2 from each, but not a 4, because 4 won't go into 2. So I'm going to take 2. And now I'm going to look at the variables, and I could take out, I have x to the third, x squared, and an x. So I can only take out one x, because I can't take out x squared, because this one doesn't have enough. And I can't take out x to the third, because this one doesn't have, or that one doesn't have. The only thing that they all can take, that I can take out from all of them, that they have in common, is just one x. So now when I do that, when I divide this by 2x, I end up with 2x squared. Remember, I'm taking away one of the x's from the 3, so I'm going to be left with 2. I'm dividing this by 2x. And when I do that, I'm going to have minus 1. Remember the negative is there. Minus 1x. Because I have 2 x's, I'm dividing by 1. I'm going to get rid of one of the x's. Same thing here. By 2x, well, 2x divided by 2x, that's just 1. So it's just plus 1. And so that's what I get when I factor out that expression. And notice, after I factor out, there's nothing that all of these have in common, right? This has a 2, but this has a 1 and a 1. So I can't divide the 2 anymore. This has an x squared, and this has an x. I could take an x from both of them, but this one doesn't have one. There's nothing left that all three of them have in common. And that's how you can test to make sure you took out the greatest common factor and not just some common factor. All right, last example. What can we divide all of the terms by? Let's start with the coefficients. I can divide this by 3, and that by 3, and that by 3. I can't divide all of them by 9 or by 12 because those won't go into 3. So I'm going to pull out a factor of 3. Now, and actually I'm going to write that. I'm going to write that over here. Okay, now, looking at the x's. I have an x squared, so I could take out 2 x's from that. But I only have 1 here, so I can only take out 1 there and 1 there. So they only have 1 in common. So I can take out 1 x from everything. But I also have to look at the y's now. So I have 1y there, 2 there, but I can't take out 2, I know, because I only have 1 over here. And I have 1 here. So I only have 1 in common. So I can take out 1y. So now what do you have left when you take out 3xy from everything? And remember, when I say take out, I really mean divide. I really mean divide every term by the 3xy. Well, this is just 1. X squared over x, I'm taking 1 away from the x squared. I'm going to have 1x left. And the y is gone. Y over y, that's also 1, right? So that's going to be just a 1. There's nothing left there. Now, divide this by 3xy. 12 divided by 3 is 4. X over x is just 1. Y squared over y is y. And then finally, divide this last term by 3xy. 9 divided by 3 is 3, so I put my 3 in, and it's plus. And then x cancels out, y cancels out, and so that's all I've got, and this is my solution. And so remember, we could check our solution by distributing our greatest common factor and seeing if we get what we started with. 3xy times x is 3x squared y. 3xy times 4y is 3 times 4 is 12. X, and then y times y is y squared. And then 3xy times 3 is 9xy, which is exactly what we started with, so we know that we did it correctly.